Okay, so we have the car payment, the rent, utilities,
and the repair bill.
ah.
All right. Hello, everyone. Welcome to the stream. Hope everybody's doing all right tonight. Just give me a second here to get set up, and we will go ahead and get started. So, for those of you who are just tuning into the stream for the first time, this is a stream where we are developing a game engine from scratch using C and Vulkan. We are using very few libraries. We're using basically the standard C library, one library to load images, and one library to handle fonts. And other than that, we are pretty much writing everything from scratch. So the idea here is that we build a game engine from the ground up and show a way of doing that. This is not necessarily the only way to do it. This is just the way that I have chosen to do it, to show a valid implementation of what a game engine might look like built from the ground up. So with all that said, this began as a series on YouTube where I had 80-something odd videos that were pre-recorded, and I recently switched to a streaming format so that there'd be a little bit more value obtained from that. At least that's what I figure. So the thought process is that when I run into issues, you guys can see how I troubleshoot those things and hopefully gain an understanding of how some of this stuff works. Because having something developed that's nice and neat and clean and prepared is great for a tutorial series, but isn't really necessarily realistic. So the goal of this is to be somewhat realistic and show that we have something being built from scratch and show the issues along the way. So with all that said, last time we actually ran into some issues where we were trying to sort of rework the way that our lighting worked. And we got some pretty interesting results. So just to be sure that we're not going to be out of date here, I'm going to go ahead and clean and rebuild everything. And I'm also going to do a post build, which is going to build our shaders. I really ought to rename that at some point, but there we are. And when we run this, it does run successfully. However, we get this rubbish. And when we load in our scene, things aren't looking much better, right? So generally, when you see something that looks like this, where it looks like your geometry is sort of coming in correctly, but you've got a lot of artifacts on the screen and so forth, it generally means that your data isn't coming in the way that you think it is. And I suspect here that this is some sort of memory alignment issue having to do with the way that we're passing in the data from the shaders. So with that, we're going to go ahead and do a little bit of debugging using a program called RenderDoc. RenderDoc is a sort of standard industry standard program for troubleshooting rendering issues. Now, I will point out that this render doc is only available for Windows and Linux. So if you're following along on Mac OS, you'll have to use similar steps that are available using Xcode. But however, we're going to show render doc here because that is the standard that we're using, right? So what we're going to do is we will... Oh, we have an update available. I should probably do that at some point. We're going to go to Launch Application. And I'm going to load in my last settings, which is my testbed exe, just because I've already done this. But if you haven't before, you can just, in executable path here, you can browse to wherever that is on your disk. For me, it's C development Kohi bin testbed exe. We want to make sure that working directory is set to the bin directory, which it is. We want to, I think these are all default options actually. We do want to allow full screen and allow vsync. We are, at least I have this on by default, is to queue capture of frame 0, which means as soon as we render a single frame within the application, this is going to catch that frame. So what we're going to do is I'll go ahead and do that. And then we'll take a sample of another frame and kind of walk through some of the data that's available in this program, right? Because I feel like this is a good opportunity to sort of explore this a little bit. So I'll go ahead here and launch. And what this will do is it'll go ahead and launch testbed, just like we're doing it from the Visual Studio debugger, except we're attached to it through RenderDoc instead. So we see here that we've captured the very first frame that got rendered, and we could step into that if we want, but I'm going to go ahead and capture another frame just because I want to make sure that we're fully loaded and ready to go. So to do that, as it says up here, F12 or print screen to capture. I usually just use F12. And you can see that it's worked here in the background. So if we go ahead and switch over to RenderDoc real quick, we can see a capture of our frame here. And this is not simply a screenshot. This actually contains a whole bunch of data, right? So we see here that we have a timestamp, how large the actual set of data is, the frame number itself, this is the 1597th frame that's actually been drawn. So if we click into that, we load up all kinds of data. So I'm not going to go into this in depth, but I will at least go into it a little bit so that you guys can kind of get an idea of what this might actually give us. So, oh, Norland, thank you for the lurk. Appreciate the support there. Appreciate that. The first couple things that we want to point out is we have this event browser over here on the left. Let me actually expand this window here so we can see a little bit better. There we go. And so we have event IDs here, and those aren't necessarily too important to us yet, but we can see that our various passes are available here. So we can see here that we have a clear pass, right? So that's basically just where we've done our queue submission, copy buffers, and all that stuff, clear the screen. We have our color pass, which is our first color pass. So this is the skybox that gets drawn in the background. And so if we actually go to Resource Inspector, really quickly, I just want to point this out as well. You'll see that there's all these resources, all these Vulkan resources that we've actually loaded here. But the first thing that I want to point out is we have these 3 swap chain images. So if I click into one of those guys, I can hit view contents over here. And so in our color pass number 1, we have a command begin render pass, draw indexed. So we can see that actually appear here on our outputs. So that's our skybox. And then we have end render pass, right? Our color pass number 2, we begin the render pass. So again, we have this guy here. This is our color buffer here. And then this is our actual depth attachment that we have there. And then we can say, take a look at draw indexed. I think I have the wrong swap chain image open here. This is 1159. That is 1160. So let me open up that. This is what I want here. So we have draw indexed, so that's going to draw the first cube, the second cube, and the third cube. And we can see here that the data that's coming in for that is just wrong. So this is actually kind of what we need to look at. Okay, so what we want to do is first we can take a look at the mesh viewer if we want, and we can see that mesh. It's just a cube, right? We can select the various faces of it and all that makes sense, right? So everything in our vertex shader is likely working correctly, right? Because we actually see this geometry represented here. Now this may be a little bit harder for you guys to see. Let me change this to maybe a solid color so that you guys can see that. And you can see here that I've got a square here, right? So just the wireframe might be a little harder for you guys to see on the stream, but there we have it. And so that's our vertex shader in. Our vertex shader out looks like that from our perspective. And the other thing that we want to look at is we want to take a look at some of our commands down here. So we have, let's look at, I guess, probably this first guy here. So we don't have any geometry shader, no tessellation shader, so there's not going to be anything there. If we go to pipeline state, we have all of our various pieces of the pipeline here that are actually in use. So we have a vertex shader here, we have a rasterizer, our fragment shader, and this is kind of what we want to look at. So we have our object UBO, and if we click into that and expand this down, we see that we have a few things in here. So we have here our variable dirlight as at byte offset 16. And then if we look at within the individual properties themselves, we can see what the byte offset is, right? So we have 1632, this one is 48, 64, and so on, right? And so what you may or may not have noticed is the fact that even though we are technically only dealing with three numbers here, 3 floats for a position, that the offset for the color is actually pulling in that last value, right? So to illustrate what I mean, let's pull up our material system. So what we should be looking at is essentially we have a directional light here that gives a vector 3 and a vector 4, right? So this is the position, the direction, and this is the color, right? So let's focus on that one first. So if we take a look at direction, we see that we have this value being pulled in correctly. So that actually looks correct. And our value for color does not look correct. So interestingly, what's happening here is it looks like we're getting negative 5.5 for our alpha, right? So color is RGBA, right? So we have this this alpha being pulled in for our color, which is obviously wrong. Now, if we take a look here, negative 5.5 just happens to be the next spot in memory right here, right? And so what's happening is because we don't actually have a 16-bit alignment here of data, right? Because we only have 12 here and then 16 here. This is getting pulled in next because the graphics card is actually looking for us to be dealing with 16-byte line structures. So that is a sort of fancy way to say that I was right about the data alignment issue. So now that we've proven that, This is about as far as I want to go with RenderDoc for right now. So I'm actually going to close this. And I don't want to save anything. And we're also going to exit our application. So how do we fix this? Well, there are two things that we're going to need to do. First, we're going to need to go ahead and change up the structures that we have here. So one change that I want to make is since the property that matters most for most lights is color, I actually want to move that to be first. We don't necessarily have to do that to resolve this issue, but it is something that I wanted to go ahead and do. The other thing is that we're going to go ahead and change direction to be a vector 4. And we're just going to basically ignore W. Okay? And this will give us our nice, neatly aligned structure that we need for our requirements in the shader. Okay? So point light's going to be the same thing. We'll go ahead and move position to the top. Color to the top, rather. We already had that there. And then change position to also be a vector 4. And again, we are going to ignore W here. Now, one more thing that we're going to have is we have vector 4, which is 16 bytes, vector 4, which is 16 bytes. Then we have 4 bytes, 4 bytes, 4 bytes, which means we need to add a F32 padding just to make this a nice round 16 bytes, right? So I'm going to change these floats to F32 real quick because they should be that. And that should be all we need to do for our structures here. That does mean that we've broken a couple things down here, so we need to fix those. So I'm going to delete this line here, swap these two, change this to a vector 4, and then for the fourth property, I'm just going to go 0.0f, right? So that's that one. These, again, need to be swapped. This needs a 0.0f for the padding there for the W. And then down here at the end, we need to add 0.0f for the padding. Okay. Wow, why is that alignment so weird? Expected an expression. What are you doing, alignment? Did I miss a comma somewhere? I don't think so. Whatever. Anyway, so obviously we need to do the same change here. So we'll swap those two, change this to a vector 4, add a 0.0f there, add a 0.0f here for the padding. All right. Now, let's just build this real quick because IntelliSense is being a little bit of a bananas at the moment. Okay. Yeah, what did I do here? I must have mistyped something. Oh. Those are now wrong because that should be a comma and this should be a closing bracket. Let's see. So 1, 2, 3, 4. That should be good there. That should close that off. The rest of these I think would be fine. That one's just messed up because it was the last line of the structure. Okay. So that should cover the changes that we need to do in code. The next thing we're going to have to do is make these changes in the actual material shader itself. So let's go to the shader config first, because I think that makes probably the most sense to change. And we're going to go to, first off, I kind of want to reorder some of these things. I want to put the samplers first, right? So it's just a little easier to identify what's going on here. And then instead of struct 28, that's no longer going to be valid. That's 32 bytes in size. And then our struct 40 is now going to be 48 for both of those to account for that. And then I think that's actually all we need to do there. So that should be aligned nicely. Now let's head over to our fragment shader, and we will make the changes there as well. So we reversed color, we put that to the top. We set direction to a vector 4. We set color to the top, position as a vector 4, and then we have a float padding here. That's obviously going to cause some failures down here, but I'm going to go ahead and post build, just because that'll tell me exactly where they are and I don't have to go searching for them. So if we expand this a little bit, so line 106. Let's see. Okay, so light.direction. Direction is now a vector 4. Yes. So we actually just need to say light.direction.xyz. And that means we'll also have to do that here. So .xyz. Okay, so that's that. 106 and 108. 126. Light position. So that's also going to be XYZ. Let's see, so 126. I think that's going to be it for that one. And then 133 is going to be light position.xyz. Right, and that's just to ignore that W component. And incidentally, we'll be having more properties that actually are going to fit into these lights, so we'll eventually wind up using those for other things. But for now, we're just going to sort of zero them out and ignore them. So let me post build again, see if I missed anything. Okay, so that's done. So now that those things, I think everything should be aligned. So let's go ahead and run. And the results look promising so far. So let me just hit T to swap out our texture here. And I'll go ahead and load. Right. Okay, so we're back to sort of square one where we were before, with the main difference being that we are now dealing with a light that has been passed in from the C side instead of being hard-coded in the shader. So that's great. How do we then go about sort of proving this, that this works, right? So let's go ahead and just prove this by changing these colors in code. So we can do that by going back to the material system, and we can just change the color, right? That's probably the easiest way to go ahead and do it. So the directional light I'm not going to change just yet. Actually, yeah, let's go ahead and change that. Let's see. So we've got sort of a darker color here. Let's crank up the blue on that to like 0.9, so it'll be super obvious, right? And we'll build. And we'll run. And we'll load. And now we can see everything's got a very blue tinge to it because of the change in directional light color, right? So I'm going to set that back because I like the color that was there. However, the point light colors, let's see. So our color is RGBA. So this is the green one. So let's go ahead and make that, let's go ahead and make it RNG. I think that's going to make yellow. And then the red one, we'll go ahead and make this magenta, right? By adding some blue to it. So we will save this and build and run. And load up our scene, and we now see our new light colors, right? Great. So we now have our lights actually being loaded in from code. So that is pretty awesome. One thing I'm going to do also is I want to go in here to the shader, and we had our temporary lights in here with our to-dos. We're going to get rid of those because we don't need them anymore. And I think everything else in here can stay for right now. Yep. Okay. All right, so that is our lighting changes, at least the first phase of it completed, right? We have all that stuff being loaded up using our uniforms as we should. Now, the way that we've done this up till now is it's a bit rubbish, right? We have this local uniform object here, which is actually just got two hard-coded lights in it, right? And then we use those lights down here, and we just add the results as we go, right? And this is okay, but it's hardly flexible, right? So we need some sort of way that we can say, how are we going to go about setting, multiple lights, right? Maybe we want, I don't know, like 8 or 10 lights in the scene, right? And there is, obviously, there's some performance implications with this, right? The more lights that you have in the scene, the more work you have to do in the shader and so forth. But I think on most of our machines, it shouldn't be a big deal to add a few more. And so what we're going to do is we'll go ahead and add a few more. But we're also going to do it in such a way where we can have a variable number of them and not have to edit our code in the shader or really the material system either, and just be able to pass through the number that we have and the actual data. So what do I mean by this? Well, instead of just having a couple of point lights here, what we're going to do is we are going to, we'll say const int max point lights, and then we'll set that to, I don't know, 10, right? And instead of this, we'll say point light p lights and create an array using this max point lights. Okay, and then we're going to get rid of these. And what this is going to do is this is going to allow or reserve enough space so that we can actually come in here and have up to 10 lights. Now, there are several issues with this, as you can imagine. A, we've hard-coded a maximum value here. B, this is always going to reserve that many, even if we don't want to use that many. But there's also another thing of you can't have variable size arrays in your shader code, right? Whenever you have an array, it's got to be a constant size. And so another thing that we could do is we could pass in, let's say I guess we'll just do a int, and then we'll call this num lights. And here we'll pass the number of lights, right? So obviously we'll have to do some checks within our C code to make sure that this num lights never exceeds this p lights structure, right? But we're basically going to have to keep our C code and our shader code a little bit in sync so that we know how to deal with this. And I'm okay with that for right now. We'll come up with something more flexible in the future, but we're just trying to get sort of a simple renderer up and running for now, and we can make this more robust later on. So with that, let's go ahead and so we're going to need to take this 10 and change up our struct, right? So we have the size of that times 10. So that's going to be 480, right? And that's going to be our, what do you call that? P lights, right? And then we're going to get rid of P light 1. Okay. And so this accounts for the entire size of all of our light structures, right? And 10 might wind up being too much. That might actually be too much space. We'll have to see. But for now, this is what I'm going to roll with. So we have that, and then we'll need to go into our, one more thing. We need to add our number lights, right? We need to add that. So right before our shininess, we need to say uniform equals. And then this is going to be a I32, which actually I suppose that could be a U32. Yeah, whatever. It's going to be scope of 1, and it's going to be called numLights. All right. All right. So our material system is going to be changing slightly. So we have our material locations here. So we're just going to go up here, and we're going to rename this to P-Lights. Whoops. That should be P-Lights. Right. And then this one is going to be num. That should be num P-Lights, actually. Okay. You know what? Let's actually change that to underscore, so it's not num Plights. We don't want any plight. Okay. So you know what? Let's actually change that to shader too. Num P-Lights. Num P-Lights. Okay. And we're going to have to modify our shader to actually work with this as well. But let's go ahead and do the material system first. So we'll come down here to the code that uses this. And P-Lights is going to just be P-Lights, and num P-Lights is going to be num P-Lights. So we have that. All right. And then what we can go ahead and do is instead of having this these individual static lights here, right? I'm actually going to create a static point light array called P-Lights again, with 10 spaces in it, right? And we're just going to zero out the entire structure, right? That should start us off at a decent point anyway. And then we will come in here and say P-Lights sub 0 equals this. Get rid of the static, right? So we're just going to kind of fill these out, if you will. And instead of obviously setting these equal, we need to say color is equal to vec4 P-Lights position equals that. Constant f equals 1.0 f, if I can type. Linear equals 0.35 f. What's the next one? Quadratic equals 0.44 f. And padding is equal to 0, right? And technically we don't need to set padding because it should already be zeroed out, but we'll go ahead and be explicit and do it anyway. All right, so that is the first element of the array set. The second element we can just do by flipping the index, copy the color, copy the position. And I think these other properties are actually the same. So yep, so those can go away. We'll set P-Lights to P-Lights. So we'll set that. And then number of P-Lights, we are going to set to, let's go ahead and do, right, static is not the way to do this. Obviously, this is very temporary code. This will be stored probably by our scene manager eventually. But P-Light count, that's an I32. And we'll set this to 2 for now. You know what, let's go ahead and crank it up to 3. And let's fill out a third one, just so that when we actually get in here, we can actually see this working right away. So I'm going to set this to index 2. And our location, let's see. So the first one was at -5, -5. This is at -5. So let's make this a +5, right? We'll go ahead and do the color on this one. Let's change these colors again, actually. Let's do red for the first one. So just pure red. We'll do green for the second one. Right, just pure green, and then pure blue for the third one. And then maybe we'll create some other ones that are mixes of those colors as well. But that should give us something there. So we have that set to 3. Then we want to useplight count here. Right. And I believe that's actually everything we need to do in code. So I'll go ahead and build that. I'm not going to run it just yet because we actually have to modify our shader. So back in our shader, this is now an array, so we have to treat it as such. So what we're going to do is we are going to set up a loop here, where we say for, I guess we'll say int I equals 0, I is less than object ubo dot numpilights, and then ++ I. And we're just going to take this first line, we'll comment out this second one. And here is how we're going to accumulate the light. So we will say calculate point light, and instead ofplight 0, it's going to be plights sub I. Okay. And everything else should be able to be taken as is, right? So we should be able to loop through those and be just fine. All right. So I'll go ahead and post build this too. Hopefully I typed all that right. Looks like it. And let's go ahead and run and see if we messed anything up. All right. So let's load up our scene. And yeah, it looks like we host something. Because I don't see any lights, actually. We switch to lighting. Lighting only. Yeah, it looks like something is definitely not right here. And it might be, I suspect, it's going to be another alignment issue. I suspect that it probably does not like the way that I have put some of these properties in here. So let's just examine this real quick. So we have numpilights here coming right after that. So that's going to be 4 bytes. This is going to be 4 bytes. I don't think I need to pad that, do I? It's a good question, actually. Did I do something wrong in the shader config? No, I said that's an I32. Numpilights comes after plights. All right, so let's actually step through our code here and make sure that this is actually doing what we think it's doing. I also want to actually do shader system. Let's see. Create. No, not shader system, shader loader. This guy. I want to make sure that it's actually greeting our properties correctly. We do have an I32 in here, right? Yeah, we do. Okay. Just want to make sure that's being hit real quick. It is not. That is interesting. It just loaded right up. Why would that be the case? All right, if I do here, okay, what am I missing here? Why are you not loading? Do I have the wrong thing set? Load. Oh yeah, I missed that ad break, didn't I? Wow, you redeemed 2 stretches. Well, I can only do one. Roberto. Sorry. Tell you what, I'll do another one in a little bit. Deal. Cool. So I did solve the problem from the last stream. I don't know how long you've been watching, but I did actually solve that problem. I've now moved on to kind of expanding it a little bit and figuring out another thing that I kind of ran into. Oh, these are attributes. That's why I'm not hitting this. Yep, that would be why. Uniforms is what I need to be breaking on. Right here. Yes. Okay, so it did detect it. And the uniform size is 4. So the name of this is... How is the name of this? Oh, that's probably the previous name, I'm guessing. Let's see. Where is the name? It's probably going to be up here somewhere. It's been a bit since I wrote this code, so I don't fully recall where everything is in here. Should be right in this section, though. Fields. What's the scope? Oh, here it is right here. Okay. So the number of P-lights is size of 4. So that should be fine. That's an int 32. So that should be correct. But for some reason, our lighting is all kinds of wonky. So I think I'm going to have to crank up RenderDoc again. And see if I can have look at this and figure out why. All right, so realistically I should be getting them here. Let's go ahead and take a capture. And it's going to be render pass 2. So our draw index here, we want the pipeline state, fragment shader, take a look at what is in here. NumP lights is 0. Well, that's definitely not the case. Byte offset 528. Is the directional light loading incorrectly? Let's see. So here's our directional lights. I suspect all of this data is probably loading incorrectly. I think it's just that count that's wrong. That's probably causing the whole thing to fail. But let's go ahead and look here. Okay, position looks correct. Constant. Linear quadratic padding, that looks correct. Okay, let's check the second one. Yep, data for the second one looks correct. Data for the third one is probably also going to be correct. Yep, it is. And the fourth one should be zeroed out. Okay, so it's not... The lights aren't messed up. Because we are passing even zero data there, but it's this, for some reason, is not correct. You saw the plight of the P lights, yeah. Yeah, I didn't want to add plight. It just seemed wrong. Especially multiple plights. Okay. Oh, sweet. Shininess is also 0. So both of those things are not loading incorrectly. Okay. So that kind of tells me what I need to know. Let's close render doc. All right. So the P light count is here. It's 3. You're loading that in here. And then the shininess comes in afterwards, which is... That's technically done up here, but again, that shouldn't matter. I'm passing the address of that. Interesting indeed. Oh, you know what? I'll bet I know what it is. I don't think... Did I do a post build? I don't know if I did. Get rid of this breakpoint. Nope, still wrong. Okay. So I must have done... I don't think I have to round that out, but maybe I do. It's interesting that both of these are coming in as 0. You know what, let me do something stupid here. Let me say U32 S equals, maybe I'm counting wrong, size of P lights sub 0, and then just to shut Clang up, I'll say if S. And I'll put a breakpoint here. It should be 48. It is 48. And this one should be 32. it is. So 32, 48 times 10. Then we have an I32 and an F32. That should be fine. Get rid of this. I wonder if, since this is now much larger, I wonder if maybe there's some sort of bug in the calculation of the overall size of the uniform buffer. Let me see. So when I load this up, you know what? Actually, let me test this too. Let me make sure this is actually coming in. So the first one should be 32. The next one should be 480. Okay. Just going to step through some of my logic here. Uniform name, uniform count, size of shader config. All right. What is this line? It's probably the last. This is the P lights. That's going to be, there it is. Shader instance. Yep. Okay, so the scope is correct on that. Stages render past. Okay, so that's it for that line. This is shininess. So that should just be a 4-byte float. I'm pretty sure that is getting loaded correctly as well. Right. So the model, I'm going to skip that one. And that's going to be the next file. Okay. So why then? Let me see, when I load this up, maybe I'm doing something wrong in here. So the directional light, the PL lights array, and the number of P lights. I wonder if I have to set those individually. I can't imagine that I have to do that. No, because the data was being set correctly in the shader, so it's not that. So we do have 10 and 11. So we've got the config. Material's been loaded. I guess I could put a breakpoint in. It's going to relax a little bit here. So I guess I could put a breakpoint in where I'm actually setting these things and see what value is being copied over. So right here, so the material shininess is 64. That was one of the things that was zeroed out. I wonder if it's the static data that's messing things up. Set uniform. Bound UBO offset, uniform offset. 276. That seems wrong. 276. Mapped uniform buffer block. So it is 512 is the offset. I wonder if this is under, this is not under 512. This is over. Right, because we have 480 plus 32. That right there is 512. Plus another 4 and another 4. So that's 520. But yet our mapped uniform, or our bound to UBO offset is only 512, which should not be possible. Okay. Object state offsets. So I have a feeling that there's some sort of bug here when I'm calculating the alignment. Given the entire size. Hey, Thorgus. Finally catch me in the act. Yes, welcome. Glad to have you here. I'm just troubleshooting some data issues with the shader at the moment. Object state offset. So let's find all references to that. Object state. So where are we actually getting this offset? Render buffer allocate. Because basically what we're running into this is saying the bound UBO offset is 512, which should never be possible because our UBOs are 520 bytes, which means it would have to be at least that. Plus whatever padding is going to be required by the graphics card for the size. Like a lot of NVIDIA GPUs require them to be sort of aligned to 256 bytes. I don't think mine is one of them, but I know this is definitely not right. So I guess it would be the uniform offset. Is what we actually need to look at. Oh, wait a minute. Is that the uniform within the beginning of the uniform offset? Global instance. Oh, so this is from the beginning. No, that actually does make sense, I think. Because this is for that uniform, so it's its offset before 276. The bound UBO offset. Yeah, this is wrong. The uniform offset doesn't seem right either, frankly. Get aligned range. Okay, so that's for push constants. I don't want that one. Shader UBO size. So is this not... How can the UBO offset only be 512? Object state offset. Let's do... Search for this. In the instance uniform buffer. Yeah, so that does make sense. Wait a minute. That's... UBO stride. Maybe that's what I'm looking for. That doesn't make any sense either. How can the UBO stride only be 320 when obviously our shader config is much larger than that? How can that only be 320? That is not making sense to me right now. Let's look at where the UBO stride is actually set. Posture check. Damn it. Okay, I'll sit up straight. Alright. So let's see where the UBO stride is actually set. So we are doing a get aligned required UBO alignment. So we have 64 in this case. Our UBO size is 280. Where is it getting? Am I even looking at the right shader here? Now I'm really wondering. Built-in material shader. The global UBO size is 160 with a stride of 192. That makes sense. But how is the UBO size here 280? Where is it getting the 280? That's like half the size it needs to be. Less than. All right, let me relaunch the application and see what we got here. So this is the skybox shader, so we can skip that one. Here we go. Built-in material. UBO size. Let's see. I know it's way down the line, but what kind of game are you going to make with this engine? I'm actually going to make a few different types of games. So the first game we're going to make is probably going to be something super simple. I don't know how much I want to say about it right now, but it's not going to be like anything super fancy with like crazy physics or anything like that. It's going to be a super simple game to make just to kind of test it. Because we're actually going to make the first game with this before we even make an editor. So we're going to be able to piece it together using our application code. And we're just going to kind of test things out before we even build an editor. Brick Breaker, something a little bit more than that, but yeah, not anything too crazy. Kind of like an arcade game, I guess you could say. More or less about that level of complexity. But yeah, I've got several different projects planned for this as we continue. So the idea is that as we add major features to the engine once it's viable, that will make a game to sort of test those things out. So we're not really to the point yet where the engine's viable. I mean, theoretically, we probably could make a very silent game for it, right? But ideally, we need some way to, load scenes and have audio and things like that. So there are a few things we're going to have to do, but what is it, the dream game? RPG, MMO? I saw your Final Fantasy and WoW videos. So yeah, I am an MMO fan, but I know better than to tackle an MMO project on my own. Those require resources that I just simply do not have the access to, and funding that I do not have the access to, and teams that I don't have the access to. MMOs cost millions of dollars to make. Obviously, I don't have that. So I have thought of a couple of multiplayer ideas that have come to mind. There's a few things, but do I need a PM? I know a few guys. Yeah, I know you do. Yeah, there's there's a few ideas that I have in terms of what I want to do there, but those things are obviously quite a ways off. But the idea is as we expand our engine, we want to build better and more complex games, right? Like I think it'd be while an MMO isn't really possible, I could see some sort of maybe action RPG being possible, or some sort of very non-traditional RPG. That could be possible, or maybe like an FPS RPG, something like that. I've got a bunch of different ideas, things I'm kind of tossing around in my head. Just haven't really landed on anything yet. Cool. TNT, hello. Super extra late today. No, that's fine. I actually started like 5 minutes early, I think, but yeah. Welcome. Good to have you here. I am currently debugging an issue with basically my UBO size not being what I think it should be. So more or less, I'm basically having issues with data not coming through in my uniform buffers. And I think I might have found the cause, but I'm not 100% sure. I'm just kind of troubleshooting at the moment to try and figure that out. Let's see. So we have... thanks for sharing. I'm not holding you to anything. Don't worry. Yeah, just excited. No, that's no worries. Most looking forward to the editor and tool programming. I am too, actually. I'm really, I really want to get the editor up and going, but in order to have an editor, you have to have something to edit. So it kind of complicates things to not have, the actual core engine here yet. So, but yeah, I've got lots of ideas behind that, and I've already at least kind of banged around a few ideas of how I want to put the editor together. So I want to go with something a little bit non-traditional on that. Okay. So this is our required UBO alignment. Our UBO size is reported as 280, which just doesn't seem correct at all. So I guess every time we add a uniform, we add the entry.size. Okay. So it may be the code that's adding the uniform that's doing it. Let's see. So that's add sampler. So I don't need that. This here is what I need. Okay. So I'm going to restart the application again. And I think this shader is just going to be the skybox. So I guess let me do shader name just so I can kind of see what shader we're on. That's fine. This is the material shader. Okay. So we're basically going to step through adding our uniforms here. So our uniform count is 14. So let's step into this. Step over a few lines here. Definitely don't want to have to go through this every single time. If it's not local, it's not. Locals aren't till the end. Entry offset. So UBO size at this point is 0. So we set hash table. It's not a sampler. It is global. Right, so we can definitely set a breakpoint there. Let's continue. Type is uniform matrix. Let's go with scope. So that's global. We can skip that one. Config scope. So that's a global. We can skip that one. Skip that one. Skip that one. So this is an instance. So this is diffuse color. So that should be 16. Yeah, that's a vector 4, so that should be 16. Okay, so that's correct. Next one is, let's do this. Config name directional light. So our size is 32. And let's actually do shader. What was that? UBO size? 16, right? So that should now be 48. And it is. Okay. All right. So the next size is 224. And this is P lights. Why is that coming in as 224? That's the problem. For some reason, the config thinks that this is... I bet I know what it is. I bet I know what it is. Yep. Okay. I found the bug. So... what's happening here is we are overflowing the size here. I don't know why I didn't think this was going to happen, but basically we have a U8 here for the size, which has a maximum size of 255. When we pass a number larger than that, it's going to wrap around, which is why we are getting the weird ass size. So I'm going to change this to a U16, which should be big enough. Build. Talk about an obscure error. Okay. And I'm going to run. And I'm just going to actually... I'm going to trust that all of these are going to go through and work. I'm just going to let it rip. All right, so here is our application. We'll load the scene, and voila, what do you know? It works. So now, now that we got past that super annoying bug that would have definitely tripped us up later anyway, we actually have 3 lights in the scene. So we have our R, G, and B. So that is pretty sweet. So now we actually have a variable number of lights that we can include in the scene. And to prove that that works, I will go into, let's close some of these other things here. Shader system, I don't think I need that open yet either. All right, so to prove that that's the way that that works, I'm going to change this counter to 1, and we should only see the red light. So I'll build, and I'll run. Because basically what's going to happen is it is going to pass all the light data, but because I passed a 1 as the number of lights, it is only going to see or render that first one. So the cool part about that is now adding lights is just adding something onto this array, which is kind of sweet. However, this is, as I mentioned, a super hack. because we are statically declaring data here in line and just setting it, and that's super crappy, right? These really should be objects that we can add into the scene and then pull for them and be able to set it that way. So we should be able to query for, hey, how many lights do we have in a scene? How many point lights do we have in a scene, rather? And what are they, right? And then be able to pass those things in to our shader and have it work dynamically without having to do all of this. The other thing that this would do is we should technically be doing this logic in our game library. And then that would also be an item that would be hot reloadable, right? We should be able to change these things on the fly and sort of recompile our game library and have that hot reload. So in order to do that, we're going to need something to actually manage these lights and then some way to go ahead and retrieve those things. So there's a couple ways that we could go about doing this. The easiest way would be to have some sort of a light manager that the material system can query, and the light manager would just return a directional light, a series of point lights, a count, things like that. That's one way of doing it. Another way of doing it would be when we actually implement our scene to say, hey, scene, give me the number of lights that you have that are in a specific area, right? And ideally, we should be able to change these things out depending on where we are in the scene. Turn them on, turn them off, render them, not render them, things like that. And that actually brings me to something else that we're eventually going to have to change as well. We're actually going to need another scope. Because I did a lot of thinking on this, and I don't think the scopes that we have right now really totally 100% make sense when it comes to lighting. So let's talk for a moment about that. So I'm going to, I'll open up our good friend Paint here. Let me just, where is the tool here? All right. So size, let's make something kind of large here. So let's say, for instance, that we have a couple of objects in the world. Let's see, white, right? So we have an object here. We have another object over here. And let's say we have an object, I don't know, here, right? And then let's say we have an encompassing object around all of them, right? And then we'll say we have a red light that's like here, right? We'll say a green light that is, I don't know, like over here. And a blue light that is, I don't know, here. And a yellow light that is here. All right. And so these boxes basically represent our meshes in the world, right? So we have a few small meshes, and then we have this big room mesh. And ideally, what we want to do is have a scene that knows what lights are within each individual object. So we should be able to query, say, hey, scene for this particular object, what lights are within range? So the answer for this one would be just this red one. And then when we go to draw this particular object, we would just pass this red one with a count of 1 over to the shader. And that would be how that got rendered, right? That would keep us from having to do any calculations for this yellow light or the green light or the blue light when they don't really apply to this particular mesh. If we drew this one, likewise, we would also pass the red, but we'd also pass the yellow, right? Because this particular mesh is within range of both of these lights, right? So it's within the light radius and so forth. And so we would pass a list of 2 with those pieces of data, right? And then this guy over here, well, he wouldn't see the red light or the yellow light. He would just see the green light, right? So we would just pass a list of 1 with the green light. And the only one that would actually have this blue light passed whatsoever is this large mesh here, which would actually take all 4 because all 4 of these lights are within range of this massive mesh here, the room or whatever you want to call it. And so ultimately we're going to want a scene that is capable of doing those things. And that's ultimately the direction that we're going to go. What that means is that these light transforms are going to have to change a little bit more often than our material instance, right? Because we could have the same material applied to this one and this one, right? But they need different lighting data. And so the way that we would have to start thinking about this is, well, we need something that's passed more often than the material instance, which defines, the surface properties between these two, right? Because those are in common. But less often than, say, the transform of this thing, right? Because we don't necessarily want to try and pack that into the local scope, because the local scope is using push constants, and our light data is kind of big. Now, there are ways around that as well. We could pass technically all of our light data to a storage buffer and then access that by index, and maybe that's the way we'll do it down the road. But that's a little bit more work and a little bit more robust than we need right at the moment. So what I'm thinking is, for right now, I'm probably going to go ahead and just leave it at the material instance level and just pass all the light data all the time and just have a hard limit of 10 lights in the scene for right now. And then, we can just render it that way for right now. And then once we want to sort of optimize that, we'll kind of change up how that works, right? So I hope that makes sense as to what we're going to be doing. All right. So with that said, I guess we probably could go ahead and start transitioning some of this stuff over to our game code, because we don't really want or need that to be here. So what I'm going to do is go the light manager route and just have sort of a light system, for lack of a better term. And we're going to create a light system and then query that for this data. And then, we could just sort of change up the light system to act differently later on, and this won't have to worry about it. So to do that, let's go to systems, and I'll create a new file, and I'm going to call this light system.h, and we'll do a pragma once, include defines standard stuff. Our material system, I think, is where we actually declared some of these things. So we're actually going to take these lighting structures out of here, which means we can get rid of our hack. And we're going to put this in light system, right? We might want to put these in like render types or something, but for right now, anything that's using these lights is probably going to use light system anyways. So I'm okay with having that be there. And then our material system is going to have to use be right back adds Leroy Jenkins. And we're back. Okay, so where we left off is we just are going to use our light system H here for our material system to get those types. All right, let me just build this real quick just to make these stupid errors go away. Actually, I'm probably going to need math types, aren't I? Yes, I'm going to. Include, oops, math types. All right. Like with a lot of our systems, we're going to have some initialization that happens. So we're going to have a B8. I guess I'll call this light system initialize. This is going to take a U64 pointer to hold the memory requirement. We're also going to have a void pointer to memory, so that's the memory block that gets passed. This is going to be another one of those call it twice, once to get the memory requirement, once to get the to perform the actual initialization, and then void pointer to config, right? And I don't think we're actually going to need any config for this, so I'm actually not going to worry about that for right now. So we have light system shutdown, which just takes a void pointer to the state. And let's do, I think the way I'm going to set this up for right now is just sort of have it be somewhat immediate mode, kind of, where we'll do a B8 add light system add directional, and we'll take a directional light, and we'll just take a copy of it, right? I was debating whether or not I want to take a copy of it, but what do I want to own that though? Should I take a pointer? Maybe I should take a pointer. Let's take a pointer. Let's take a pointer to a light, because that way we can actually just update the light, since the light is nothing more than just a data structure anyway. If we take a pointer to it and we store a pointer in the light system and have that actually owned by something else, then we can actually update that light elsewhere instead of having to go through the actual lighting system to update it, which means we could change color, position, things like that. So let's actually do that. And then we also have a B8 light system add point. And point light, pointer, light. Wow, if I can spell. All right. I guess since we have add and since we have add direction on add point, we probably ought to have the ability to remove them as well. So let's do that. And I guess we can just go by address, right? We could just compare the pointer directly and use that for removal. And then I guess we'll need to do a, was that an I32 that we had for the light? I think it was. I suppose we should be using U32. But where was that light count? Down here. Yeah, it is an I32. That's fine. I guess we can stick with that for right now. Light system point light count. Right, that's just going to give us the count. Gonna go get ready for stand-up night. Getting ready for stand-up now? Jeez. That's like aggressively early, Roberta. Aggressively early. Okay, so I guess for the array of them, since we only have perfection takes preparation. I mean, that's true. I have high expectations then, if this is how you're rolling. I guess I will say point light system point lights get. Just trying to think about the interface for this, because I can't use an array of pointers, right? I have to have an array of the actual thing here. So whenever I get the lights like this, I probably am going to have to create a new array of those things. Or maybe I can cache the array if it doesn't do anything, right? If it doesn't change. But I can't have an array of pointers. It's got to be an array of objects. So I think that's the way I'm going to do it, and I'll change it if I need to. But this should basically be the whole interface, right? So light system.c include light system. We are going to have to register this with our systems manager as well, because we need a way to retrieve the state. So we probably ought to go in here to, I think I put that one under core. Yes. Systems manager. Yeah, let's just add a new one here. So we need a K system type light. We'll go ahead and tie this in now, I guess. So this doesn't need to happen pre-boot at all. This could definitely happen post-boot. Register post-boot. Here we go. So texture system, font system, camera. Probably happens somewhere around there, quite honestly. Material system. Yeah, let's put it here at the end. However, I do need to include the systems. Why are you not auto-completing? Light system, okay. So here we can say if not systems manager register state, we want the light system, we need light system initialize, light system shutdown. It does not have an update currently, so we can pass 0 for that. We can pass 0 for config, because we don't have any sort of configuration. Let's go ahead and copy this. Failed to register light system, okay? Light system. All right, so at least now we should have our light system stood up for us automatically. Okay, so initialize. The first thing before we can actually figure that out is we need a type def struct light system state. I guess we'll go ahead and hard code a couple things in here. So define max point lights. We'll set that to 10. Point lights. That's going to be an array of pointers. All right, so that's actually going to be point lights, pointer, p lights, 10. Actually, max point lights. Right. So we've got that. We can have one directional light, period. This is only, So this is going to get weird when we start to talk about multiple scenes. I guess, yeah, I'm just going to put a directional light for it right now. And then we'll just say there's a limit of 1 for right now. I want a pointer to that. I think that's all we need for right now. Okay, so memory requirement equals size of our state. That's it. Okay. So if not memory, then we are just going to return true, right? Because that's all we were doing on the first call is getting the state, right, or the requirement for the state, right? Otherwise, if we do have memory, I don't know if there's any configuration that we need to do here. I don't think there is. Perform config init here. I don't think there's anything that we actually have to do. TNT, you have to leave now. That's cool. See you later. Thank you so much for joining. Appreciate it. And we'll return true. There's not really any initialization or validation we have to do here. It really is just that. If state, and actually there's not really anything there to do either. So that's nice and simple. Okay, so with add directional, we are basically going to just replace what's there every single time this is called. So the first thing that we're going to have to do is, first off, include core systems manager. And then we need light system state equals systems manager get state, and then k system type light. So we will get the state for that, and then we will simply just, actually, we can go ahead and check to see if light exists. If it doesn't, return false, right? We can say state directional light equals light, right? I guess that's probably as good as we're going to get. Let's do. No, it should be fine. All right. So all we're going to do is just replace that one. So I'm not really going to worry about that for right now. If we want to expand it later and make it a little bit more complex, we can. The add point is what is going to get a little bit more specific. So we need to do these same things. But now we're going to do for u32i equals 0, I is equal less than max point lights plus plus I. And in this, we are going to check each individual element of the state p lights. And we're going to say if p lights sub I is null, then that's where we're going to put it, right? So in this case, we'll just say state p lights sub I equals light break. Actually, no, we can return true there. If we get to the end of the array, then that means that we're full. So fail. Right, so return false. Should probably put some logging in here too, I suppose. So include core logger, k error, light system add point already has the maximum of number of lights. And that's going to be max point lights. Light not added. Return false. Okay. So remove directional is simply going to be, first off, our sanity check. Get our state. And then if state directional light equals light, right? Because we're just checking the address here. So we're literally saying if one pointer is equal to the other, right? So we're not, whenever you do this check and see, you're not saying is the content equal, you're saying is the address, or the address is equal when you compare pointers like that, right? So if they're equal, then state directional light equals 0 and return true. Otherwise, return false. Okay? And that's as far as I'm going to go with that one. To remove a point light, I'm actually just going to copy the add code. And here we're basically going to say if state p lights equals light, then state p lights sub I equals 0, and we return true. Otherwise, we did not find a match. So does not have a light that matches the one passed. Thus, it cannot be removed. Okay. We don't have, we don't have any formatting to do, so that's just that. Okay. And then the point light count is actually going to be almost the same code again. Here we go. So we're going to return 0 in this case. Whoops, actually. All right, so we'll go ahead and get the state, loop through the lights, and we'll say if there's something at that index, we are going to keep a counter where we say I32 count equals 0, and here we will simply count plus plus, right? And then down here, return count. Right, so for every one of these that's not null, it will go ahead and count that. Probably not the most efficient way to do it. We should probably cache this result, but whatever. This is going to wind up changing anyway, so I'm not really all that worried about it. All right. Now, the only thing... You know what? I knew I was going to wind up changing this interface, and now I know how. This is going to be void. We are going to pass the array here, point light, p lights. And we are going to fill that array this way, okay? So what we're going to wind up doing void is we're going to rely on the caller to call the get point light count, and then they'll use that to basically construct an array, and then we'll pass that array here to be filled in. So we'll go ahead and do this. We'll need this. Also, that probably should be a B8 actually, because it can fail because they can pass us a null pointer. So we should check for that. P lights, right? So we're gonna loop through. If there is a state P lights sub I, then we're gonna say P lights sub I equals dereference state. Oh, am I going to have to wrap this? Probably. So we'll say state p lights sub I, but since that's a pointer, we're going to have to dereference it. Right? This is not going to work because we could have fragmentation in the array. So we're actually going to need two counters. So j equals 0. So we'll use that to loop through here, but we're going to say p lights j is equal to that, and then j plus plus here. That makes sense. Okay. So that should do the thing, and then we'll return true. Wow, I can't spell return, apparently. All right. And I think that's it for our system, right? So now we should be able to... You know what? Before I move this to game code, I'm actually going to plug this back into our material system. How do I want to do this? I'm going to comment that out here. Oh, I guess it doesn't make sense to do it here anymore. It really does make sense to actually move it over. So, okay. Testbed main. We need to include systems light system. I was going to try and do this a little bit more incremental than this, but I suppose this makes the most sense. Let's see, right around skybox world meshes, UI stuff. Yeah, let's do it before the UI, right after here. So we have a directional light and some point lights. So let's actually go to the state and I'm going to have to include the light system here. Not totally happy with that, but This is temporary stuff anyways. So we need directional light. And we need, let's not do p light count. We don't need that. Let's do point light, p lights. We'll do 3 for now. All right. It's probably going to fail in some spots, but that's okay. All right, so that's the game state. Let's go back to code. And where was all that? Here we go. All right, so we'll set our state directional light to that. We'll get rid of this. We'll set, this is actually all going to be state, right? And then for each one of these, we'll say light system add direction, and we'll pass the address of this, right? And then here we will say light system add point, and pass the address of this. Looks like we're going to have adds here in a minute, so I'm just going to try and beat that if I can. So this is going to be sub 1 and sub 2. Right? So that should be that. Our material system now should not use any of this stuff. Instead, oh, did I put in the light system a way to get our directional light? Nope, I did not. So I guess it's going to have to be directional light pointer, light system get. Wait a minute, point lights get. Yeah, let's say directional light get. Ugh. That's an ugly function name, but whatever. It is what it is. So we need a way to get that too. So we get the state, and then we return state. Let's see, directional light. All right. So that's that. All right, adds. Okay, we're back. So, we've gone ahead and gotten the directional light, so we can actually just pass that. We don't want to pass the address of that. We just want to pass that as is. Now we need the light count. So we have I32 light count. That should be P light count. And that's going to be light system count. Right. And then we're going to have our array of, we need to create our array rather to pass to the next function. So we're going to say linear allocator. Do we have our frame allocator? We don't. That is super poopy. Shoot. We don't have a frame allocator here. This would be a primary use for that. Okay, this is not great, but I'm going to have to create an array here, a dynamic allocation. I don't like it, but I'm going to do it for now because we're nearing the end of the stream here. So I'm going to say kallocate size of, and this is going to be point light times p light count, and memory tag array, right? And we're going to say point light p lights equals that. Next we'll say light system point lights get, and we're going to pass p lights to that. And then we're going to update these functions here. These are going to be passed. P light count still has to have the address because that's there, but that should be fine. Okay. I think we have everything we need. Let's build this. What did I do here? Oh, we're not returning anything. Return true. Expected expression. Oh. I had to cast that. Okay. Oh, we didn't export our functions for our light system. We don't need to export these guys, but everything else we do. Just to be safe. Okay. So let's run. See if we borked anything. Hey, we have 3 lights. So that's pretty sweet. So let's actually do a check real quick on our hot reloading, right? At some point, oh, did I full screen this somehow? There we go. At some point, I must have full screened that. So we'll keep this here so that we can see that. But what I'm going to do is I'm going to change up some of our logic in our testbed main. So we're doing the assignment here. And this is during our initialization. So if I just change it here, it's not going to actually change anything. How do I want to do this? I guess I could say, let's change, we'll go for the green one, right? We'll do the second one. We'll change the color. But what we're going to do is we'll come down here to our update. Got our state. Geometries. Render flag enabled. Here's our text update. Maybe we'll do it before that, right? Because we've already done our geometries at that point. Yeah, let's do it here. So we'll set this to something else, right? So instead of green, maybe we'll do do we have Kmath? Do we have Kmath? I don't think we do. Right, so we can include that. Oh, yeah, we do. We do have Kmath. Didn't we have? Didn't we do? Yeah, K signs right there. Why is it not? All right, whatever. We should have. I guess we don't have a update clock. So we need to accumulate some time, I think. You know what? Heck with it. Let's not make this complicated, right? Let's just change this to yellow. No, that's actually going to make it, this will make it yellow, right? So we'll do that. We will go to our terminal here. We will split. Not even going to be able to see the split terminal. Yeah, here we go. Build testbedlib.bat. So when we build this, we should see that light change color. And there we are. So we can see that change color just to prove that that's working. Let's go ahead and also, let's change this to blue. And let's change this, turn off red, run this again. Oops. Got a slash there. And now it's cyan, right? So we actually got a little bit further than I thought we were going to get. So we have a light system put in place so that we can dynamically change our lights on the fly, which is kind of neat. So not only that, but we also got all that hard-coded crap out of the shader and out of the material system. And now those are owned by our game like they should be. So if we wanted to, change the position of any of these things, we could do that too. I guess that's kind of another thing I could do is let's animate the position real quick, right? Let's do, oops, position dot, let's go the x-axis, right? And we'll plus equal 0.001f, right? So make it move really slow. Save that, build. And now you can see it's moving ever so slowly, right? That might be a little bit too slow. Let me speed that up a little bit. Right, and now you can actually see that that's moving along our scene, right? So we have the ability now, if we wanted to animate our lights, we can actually do that. Send this back the other way. And now it kind of heads back that way, right? So this is where I'm going to end this. This is a really good spot. So I'm going to go ahead and call this here. I think we are actually, are we on a feature branch? Get status. We are on a refactor lights, right? So I'm actually going to merge this in. So add get commit. So we moved lights out of shader, now owned by game, and added light manager. All right, we'll go ahead and push that. And right, so now we actually have the ability to, let me just pull this up here. So we have this guy, so we're gonna just do a pull request real quick. So here's the work in progress, here's the one that we just added, and then here is our list of changes. So these are all the changes that we've made to get to this point. So I'll create a pull request and merge it in. And there we go. So we are now, let's just pull that. We are now up to date. You guys have all the same code that I do at this point. So anyway, that is where we are going to wrap up the stream for today. Thank you guys so much for tuning in. And yeah, let's see who is out there to raid. I am going to raid Team Vosh again. So if you guys aren't aware, they are a 2-person duo that is creating a MMO on their own. I think right now they're kind of in the process of researching networking, but yeah, that is a pretty interesting project. So definitely suggest you guys head over there. All right. And thanks. I'll see you guys later. Bye.
Hey, Travis. Thank you for the raid.